Okay, so good morning. Welcome to 2019. And what we're going to do is I'll give you an overview of the material we'll be covering in class, and then we're just going to jump right into it. I'm Doug Schmidt. I've been teaching this particular class for a really long time. And every year we do a little bit something new, and we have new assignments, we have different topics. And so hopefully you'll get a lot out of the material we'll be covering. So I'll start by giving you an overview of the objectives for the course, what we'll be covering here. And the first point, which we'll go into a lot more detail shortly, is there's a tremendous demand for people who know how to write programs that run on modern hardware with modern computing technologies. So mobile devices, which we'll be covering here, laptops, not so much desktops, not so much cloud environments, a little exposure here to accessing information through the cloud and so on. And what's happening lately is because of changes in the way that Moore's law, which we'll talk more about in a second as well, works, people are increasingly learning to use multi-core processors to get performance speed up. Back 10, 20 years ago, you just waited a couple of years and everything would get twice as fast. Nowadays, the hardware doesn't really get much faster, but you have a lot more cores. And so we'll be talking about multi-core platforms, how to program them. We'll be talking about how to access storage, do networking, things that rely on modern hardware and software technologies to make things run better, faster, cheaper. In my experience, having taught this stuff and used it in practice for a really, really long time, the best approaches here are not just to talk in the abstract about the theories and the concepts, but really to get down and get your hands dirty doing the actual stuff. So there'll be lots of experiences in class where you'll get a chance to apply the concepts and techniques we'll talk about. You'll get a chance to see the solutions that I come up with. I will give you personalized feedback on what you turn in. So hopefully by the end of the semester, you'll have a lot more really deep knowledge of what we're doing, and it's not just about sort of memorizing a bunch of dry facts. There will, of course, be some memorizing of dry facts as well, but it's mostly about working with the actual technologies. As you'll see, we'll be focusing both on object-oriented techniques, because Java is an object-oriented language in part, and we'll also be talking about functional programming techniques. And that's sort of newer stuff, newer being the last 5 years or so. And you'll get some experience with both. So what are we going to be focusing on? The main focus of the class will be on, by the way, don't sit in the back row, come up a couple rows. The main focus of the class will be on foundational Java and to some extent Android concurrency mechanisms. And we'll talk a lot more about what that means shortly. But basically this would be things related to what you would get if you were just using good old Java. So there's lots of Java-related stuff here. So we'll talk about Java threads. We'll talk about the Java executor service. We'll talk about the dozens, it seems like sometimes, of synchronization mechanisms to coordinate all the threads. And then we'll also talk about a bunch of Android features that are specific to the Android platform. And you'll get a chance, once again, to program with all those things. As I mentioned before, we'll be focusing on Java 8. I'll talk a bit more about what that is and how you can learn about it if you don't know much about it yet. We'll also spend some time, this will not be the focus of the course, but there'll be some discussion about how Android handles things like inter-process communication and running various computations in the background in the form of things called bound services. So you'll get a little bit of exposure to Android programming as well. If we have time, we'll also talk about some of the web communication stuff. This is subject to change because we may run out of time because there's lots of other things. And we'll also talk a bit about patterns. Hopefully everybody here has taken CS251, where you've been exposed to some of the classic so-called gang of four patterns like bridge and proxy and adapter and so on. We're going to focus on some of those here and there, but we'll focus a lot more on more modern patterns for concurrent programming, because that's really the way that Android is developed. I'm assuming that you either know or can quickly come up to speed with the following things. So hopefully everybody here has been exposed to Git before, which is a source code control management system. I think that's used in a bunch of courses, especially 251. If you don't know that, you'll have to learn that. We have office hours where you can get some help with that. I have some videos that can help you with that. We'll be doing some Java 8 stuff. You may not be familiar with Java 8. You'll learn it. We're going to be doing basically the key features like lambda expressions and method references and a little tiny bit of streams perhaps here or there. But that's also stuff I'll give you pointers on where to learn. And you'll have to know a little bit about Android, particularly about Android Studio, which is the development environment we're using. If anybody here has ever worked with IntelliJ, Android Studio is just a little veneer around IntelliJ. So that stuff shouldn't be too hard to learn. And I'll give you pointers for all that. So here's what we'll be covering. There's 4 main modules in the course. One of the key things we'll start out with is talking about Java threading and associated classes and interfaces that work with threads, things like runnables and the executor framework. We'll cover this stuff throughout the semester. We'll also be covering some of the cool Android concurrency mechanisms like the handlers, messages, and runnables, or Hammer framework, and the async task frameworks. We'll also be covering lots of Java synchronization mechanisms. Java, not so much Android, but Java has lots and lots and lots of synchronization mechanisms, built-in monitor objects, and then lots and lots of synchronizer classes that are part of Java Util Concurrent. You'll learn about all these things, and you get a chance to play around with them. As I mentioned, we might do a bit about mobile web communication if we have time, and we'll talk a bit about some patterns along the way as we have time as well. We'll probably bounce around with these topics. The main thing I want to be able to do is make sure that before you do a programming assignment on a topic, we've had a chance to cover it. Now, because I have taught this material in the past, and I record all my material, and I put all my material up on YouTube, you'll see when you get the programming assignments that even if we haven't covered a topic in class, and we will always cover the topic before the programming assignment is due, I'll often give you links to videos that I'd covered in previous years talking about that stuff. So if you want to learn about it before we cover it here, you can always go back and listen to me talk about it then. So we'll move around with various things. We'll go back and forth, for example, between threading stuff, and then we'll cover some synchronizers. And the reason for that is the assignments tend to use those technologies together, as you might expect. Each of these modules is composed of lessons. Each lesson has a bunch of parts. Each part is a single lecture and will be produced as a video in that format. And you'll be able to get access to all of these lesson parts, the videos that correspond to this stuff, as well as the PDF versions of the slides that I present here at my website. So we're actually not using Brightspace here. I use a combination of my website, which I will send you in an email shortly after class is done. And then we also use things like GitLab and GitHub and Piazza and stuff like that. And you might ask, why do we do this? Well, having worked with the Vanderbilt learning management system over the years, they keep changing it every few years, which is really annoying because you put all your content in one package and then they change it. So a couple years ago, I said, the heck with that. I'm going to maintain my own website, and that way it's always guaranteed. Please don't sit in the back, come up. That way I can change things at my pace, not Vanderbilt's pace. We'll have some questions at the end of pretty much every part, and that's a chance for folks in the class to think about what we just covered, make sure people are kind of following along. And a lot of times those types of questions also appear in the quizzes, so it's a good way to see if you're tracking what we're covering. We will have quizzes typically once a month, usually the first Wednesday of each month. Perhaps not surprisingly, we will not have it the day after tomorrow, because we won't have covered enough stuff there to make it worthwhile having a quiz. But that's usually what we do first Wednesday, or maybe sometimes the second Wednesday of each month. I will, of course, announce that well in advance. We'll probably have our first quiz in a few weeks. And the idea here is really just to make sure you're keeping up with what's going on. Not surprisingly, all the quizzes and the final exam are closed book examinations. And the best way to study for this stuff is to watch the screencasts, which I'll put here at my website, which will also be on YouTube, and reviewing the slides. That's the time-honored way of doing it. As you'll see, one of the nice things about screencasting everything is that you can go back and rewatch stuff. If I go through a topic too fast, or if you zone out and don't listen to what I said, then you can go back and rewatch it, and you can speed it up, you can slow it down. That way you can really keep up with what we're doing. I will pass the quizzes back in class. One of the nice things of having a somewhat smaller class, certainly compared to what you've been exposed to in CS 101 or 201 or 251, is that we should be able to get more interaction. So I'll pass the stuff back, and then we'll go over the quizzes in class. I'll talk more about this later. Attendance and participation is really, really, really important in this class. So sometimes I've noticed people will show up for quiz day, and then they won't show up any other time. Bad idea. You lose major points if you don't show up to pick your quiz up. How do I know if you didn't pick your quiz up? because I'll hand it back. So I'll find out if there's a stack of 4 or 5 people at the end, you lose lots of points. So make sure you show up. Another typical thing, the quizzes typically are kind of like little mini midterms, so they take the whole class period usually. So you have to show up for that, of course. We'll have a final exam that, at least in theory, could cover sort of anything we discussed in class. In practice, it usually covers the last couple weeks or so after the last quiz. So the final exam will be held in this room on Thursday, April 25th from 2 to 5 p.m. You'll undoubtedly forget that, and so I put it up on my website, which I'll show you later. So it's always on the website. You can go and find it, and that's when it'll be. Okay, we'll have a bunch of assignments in this class. I typically have 4 to 5 multi-part assignments. You'll learn more about that in a second. We'll talk a little bit about the assignment 1A today, but I'll have a lot more coverage next time, and I'll have all the material out for you probably by later today. You can use any IDE you want, but your final solution, the one that you submit as the final thing for me to review and for the TAs to grade, please don't sit in the back. Please come up at least one row. You have to have it build with Android Studio 3.2.x. I think 3.2 is the latest stable release, and Android Pie version 9, which is API 28. You'll see why that is a requirement in a second. You'll have to install the Java 8 runtime environment, which you can get here if you go to the installing software link at my GitHub wiki. Again, but you'll have all these slides, so don't worry about trying to copy down the URLs. They'll all be in the slides. You just have to click on them. And we'll be using Android Studio, which has all kinds of cool things to make it easier to build Android apps. By and large, you won't have to build an entire app in this course. In fact, you'll be focusing almost exclusively on the concurrency and synchronization portions of a really, really cool app, which I'll talk about shortly and show you later. You'll have to install Android 9X, which is Android Pie, which is the most recent version. There may be a newer version, but we're sticking with API level 28. You could probably use 29, but just make sure you use 28. All the source code for the assignments and all the examples that we'll discuss are available at my GitHub account. And so you can go to here, and I'll talk more about how you get access to the stuff. What you'll end up doing is basically cloning my repository, and then you'll work on a local copy in your workspace. You'll push your commits to your local copy. You don't push it back to my master copy. And then when we do the submissions of the assignments, you'll send me the link that you use for your GitHub or your GitLab repo, and then I'll be able to basically clone it, and then I'll edit your files, give you comments and feedback and stuff, and then you'll update that. We'll talk more about that process in a second. Key thing you'll need to know is how to use GitLab. Fortunately, you don't have to know a whole lot about it. The TAs for this class have been, they took this class before. They TA'd this class at least once. One guy has, I think this is his 3rd time TAing it. So they're very familiar with how to help you with any questions about GitLab or Git. So make sure you go to office hours. I'll talk more about the office hours in a second too. From time to time, you'll end up having to get maybe a fix or two. Hopefully the assignments are in pretty good shape, but inevitably there's always something a little quirky in one of the assignments throughout the semester. So just be prepared to learn how to do a pull from my master account to get the new versions. We'll typically have multi-part assignments. I'll talk about this in a second. And so the first part, you'll do some things, and then I'll give you some feedback, and then there'll be a second part, and I'll give you some more feedback. And we'll often add new tests and auto graders and so on into the assignment. So over time, it gets better, and you get better feedback on how everything works. The assignments are designed to give you a range of experience with Java 8 features and Android with respect to concurrency and communication. Primarily concurrency and synchronization stuff, threading and synchronizers, a little communication here and there. Again, you'll be able to get access to all this stuff. I will send this out in an email to everybody shortly. By the way, if you're in the class and you actually haven't been added to the class yet, please see me at the end, and we should be able to add you, but I'll need you to send me your email address so I can add it to my list of people who have access to Piazza and so on. This is what we're going to be doing. All the assignments are going to be based on one really super cool driver program, which I have called the Palantiri Manager app. And anybody here Ever heard of Lord of the Rings? Okay, great book. They're great books, great movies. If you are familiar with Lord of the Rings, you know they have these things called Palantiri or Palantir, and a group of them are Palantiri, and you can gaze into them. And so the whole application, which has this really cool GUI, is basically various characters from Lord of the Rings waiting to get access to a Palantir to gaze into it for a certain random amount of time. And it's super fun, interesting example of concurrent resource management with a neat GUI. And so what you'll end up doing is you will provide kind of the brains behind the GUI, doing the concurrency and synchronization capabilities with all these different mechanisms. So we'll start out with Java threads. Later we'll do some executor stuff. You'll use the Android Hammer and async task frameworks. You get a chance to play around with Java semaphores, monitor objects, concurrent hash maps, some Android bound services, and so on and so forth. So it's always been a fun example to play with. We change it around all the time to make it interesting, and it'll hopefully give you a real good sense of how to program concurrent and parallel programs using Java and Android features in a way that's visually interesting to watch. And you'll also see that the fact that there's a GUI helps make it a lot easier to debug your code, because if it stops and things don't move around, you know you have a bug. And we also have lots and lots of unit tests and stress tests and instrumentation tests so that you can get feedback without necessarily having to go to me or the TAs all the time to see what's going wrong. The way that the programming assignment grading and review is done is probably a little different from most of your courses at Vanderbilt. I find it very effective. People typically like it quite a bit because they get a lot of feedback. So here's the way it works. We're going to have a two-phase process where you first submit the initial implementation, which needs to fulfill certain properties in terms of completeness and quality. And then I review it, and then I send you back, or I push comments back to your repo, and then you will basically take my comments into account, plus the review session we'll have in class where I talk about the general issues I saw. And then you'll update those things and submit that for the final version. So, in large measure, you should do very well because you're getting personalized feedback. We're going to go over it in class. You have a chance to go to office hours. So in my experience, most people do well with a couple of exceptions. The people who typically don't do well are people who cannot submit things on time or who do just a really crummy job of trying to do the programming assignment. So if you don't like to program, if you have a hard time with deadlines, you will really, really struggle in this class. If you like to program, if you're able to keep up with things, you should do fine. First and foremost, you have to submit the stuff on time. So we'll have a process using basically Google Forms where you'll fill out a form, also very important to do, with the information that I need in order to be able to review your code. And that's super duper important. And you can find out more about this stuff here at the FAQ. Here's basically how this process works as a flow chart. So the assignment will be due, the initial submission will be due at a certain date. You will do that, you'll submit it, then I go ahead and review, give you feedback. You get a week or so to revise your program relative to my comments, and I typically determine how long to make that based on how well people have done. Then you resubmit your program, again, by pushing it to your GitLab account, and then the TA and the graders review it, give it a final grade. So that's basically how this works. Any questions about that process? So it's really, really important, A, to give me your initial assignment when it's due and follow the form. Make sure you fill out the submission form. If you don't do those things, we don't review your code, and then you're going to have a harder time with the second phase. And then after that, you get a chance to kind of fix things, and we grade the final version. Another thing, really, really, really important. I want to make sure. I almost want to send out a Google form everybody has to fill out, because inevitably, 95% of the people, not a problem. There's always a few people who don't follow the rules. If you do not come to class, we will not review your code. So you're going to do very poorly. So it's really, really important to come to class, and it's also important to participate in class once you're here. We'll talk more about that. Hopefully it is clear at this point in Vanderbilt that the work that you do is your own. I review everybody's code, so if people start copying, it's usually pretty easy to tell because I look at everybody's code, every line of code that they write. So make sure your work is your own. I give you a link to the honor statement. Hopefully everybody's familiar with that by now. And then we typically have ways of assessing the code. Nothing should be too surprising here. The key thing we have is we have auto-graded unit tests that go through and check all kinds of conditions in your implementation looking for flaws and defects. So I typically find out how well you're doing in two ways. First, we'll have you run the unit tests before you submit your code, so you should know before you submit it how well you're doing, because if it doesn't work, it'll flag errors. And then I'll review it and give you feedback. And so by the time you get to the final version that gets reviewed by the TAs and the graders, it should be in good shape, unless you're just not doing your work and not keeping up. This is not a required class. So if you don't want to follow along with these things, please drop out now. And I say that with all the love in my heart. My experience is most people do fine. There are always a few people who just don't want to do it, and then we have a big issue, and it becomes a problem. So if you're not interested in the programming, no shame, just withdraw. You'll be fine. This is the typical weighting. Typically 40% for the quizzes, 40% for the programming projects, 10% for the final exam. Depending on various things, we sometimes don't have a final exam. Depends kind of how everything works out, but that's pretty common. And then the other thing that's important is 10% participation, which is basically 5% for showing up and just being in class, and then another 5% for being involved. And being involved really means coming to class and participating, and we'll talk about how to do that in a second. So, really important, be involved. This is what, in my mind, distinguishes you, Vanderbilt students, from other places, right? People here are not just here to be passive listeners, absorbing information and doing nothing with it. It's about learning, it's about seeking stuff out, it's about being leaders and taking the initiative. So that's very, very important to me and hopefully very important to you, and this is a great chance to try that out. You'll see this is, typical disclaimer, no such thing as dumb question. Ask the questions. I hopefully be very respectful for every question. Do not feel shy about asking stuff. Because it's 10% of the grade, if you don't show up to class and don't participate, you're losing lots of points, so it'll be harder. Okay, here's a quick summary of what you're going to need to do in order to get access to the software. So we'll be using Android Studio. You can get that up here at this link, and you want to be using version 3.2, as I mentioned before. To do this, and some of you may already know this, but you'll have to download the Java 8 SDK and the JRE, or the JDK and the JRE, which you can get from the Oracle website. You'll need to use Java 8 because we use some Java 8 features. Sadly, Android doesn't support anything beyond Java 8 at this point. Maybe at some point they'll support Java 9 and beyond, but they don't. Download Android Studio 3.2. I think at this point it's no longer a beta, it's the latest version, so you can use that. And we need to use 3.2, by the way, because the auto-grading that we do uses some of the Android Studio features to do the testing. Make sure that you get Android 9, which is API 28, which is the Pi version of Android. And you'll see that there's all kinds of things you can get. You're obviously welcome to get earlier versions, but they take up a lot of disk space. So unless you're really interested in doing older versions of Android, make sure you at least get Android 28. You'll also have to create an Android 28 emulator. This is one of the wonderful things about Android. It's pretty resource intensive. If for some reason your laptop doesn't have enough horsepower to work effectively with the emulator, let me know and we'll set up a computer account on some of the instructional labs in Feather and Gill on the second floor, which have much higher performance graphics and so on. So sadly, this is less an issue. A couple years ago it was more of an issue, but Android is kind of a resource hog, unfortunately, for the emulator stuff. By the way, if you have an Android phone that's running a new version of Android, you can probably also run your examples on your phone, which is way faster than doing it on the emulator. For those of you who have an Intel processor, which is probably most of you, you can use something called Haxum, which is a virtualization driver that's used to speed up the emulator when you run on Intel hardware. So if you follow the instructions that are here, it will give you step-by-step guide to setting the various flags you need in order to be able to use the Haxum accelerator. Definitely recommend that. Way, way, way faster. OK. The Android source code is available online. You can browse it. You can download it. The Java source code is available online. You can browse it. You can download it. I am a big fan. Probably the Android source code is probably overkill for most of the class, but certainly the Java source code is pretty cool. And we will spend some time talking about some of the implementation details for it because it's pretty cool. And what's really neat about the Java concurrency and synchronization stuff is it applies many of the gang of four patterns that you probably learned if you took CS 251. So if you took 251, then you're hopefully familiar with things like bridge and factory method and strategy, and you will find these patterns all over the place in Java in general, and specifically in the concurrency utils that we'll be covering. So it's kind of neat to see this stuff isn't just for academic purposes, but great Java designers actually use it when they build their code. OK, so a few things to summarize this intro. No surprise, you get out of the course what you put into it. Be prepared to work hard. One of the things we do is you'll see that we break the assignments up into little pieces, and each piece typically has something due every couple of weeks. And that's intentional, because the idea here is not to have people fall behind. My experience is most people tend to wait towards the end of whatever the deadline is to start working on things. And that sometimes works, but in this case, it would be very hard because you get too far behind and then you do a crummy job. So rather than let people do that, we kind of break it up into smaller pieces. You turn something in, I give you feedback, you improve it. Then we have the next assignment, the next part of the assignment. You take that, you improve it, and so on and so forth. So it should be fairly steady pace, probably nothing too monumentally hard in terms of giant amounts of time commitment, as long as you space it out and keep up. And it's really important to keep up. Do not miss deadlines. Bad things happen when you miss deadlines. Huge point deductions for missing deadlines. Make sure you participate in discussions in class and on Piazza. So you'll see that this is the Piazza link. Again, I'll send this stuff out to you shortly. And that's what we use to communicate. Probably everybody's used Piazza one way or another. It's a nice way to keep track of things. All right, another big, big important thing. People lose lots of points on this. All the lecture material is recorded. You're welcome, and I will put it out shortly. Usually, it certainly will go up by the end of the day. So you do not have to use your laptops or phones in class. And I'm a real stickler about this. In my experience, when people sit there on their phones and laptops, they're not paying attention to lecture, and then they show up in office hours and they're like, I don't have a clue about what's going on. Will you teach it all for me from the start? And the answer for that is go back and watch the videos for most of the cases. So big point deductions. Not using your laptop may be a struggle. I know I'm addicted to my technology too, but for at least 75 minutes twice a week, you'll have to get along without it. So no laptops. And secondly, no shutting your laptop and then bringing your phone up and sitting there and appear to pray or something like that, right? So that's also pretty obvious too. And people will lose major points. And I don't like to do that, but that's just the way it is. And I'll remind you periodically, but this is your major warning about this. Lots of resources. We got tons of office hours. I'll show you those in a second. We have online forum, Piazza. There's some textbooks, some of which are actually really quite good. Tons of links in the slides. You see I'm a compulsive slide linker, and then all the video lectures. So there's lots of things. Obviously, if you have something you need to talk about, it's confidential, or you need to schedule a meeting, feel free to email me. But as a general rule, get in the habit of using Piazza as opposed to sending me email, because if you use Piazza, then the answers that I give or the TAs give will help everybody. Because chances are, if you have a question about something, I pretty much guarantee you other people have that same question too. All right. Clearly, this is a great field. If you haven't noticed, people with computer science, undergrad experiences, and master's degrees and PhDs are the big winners in the modern tech-centric economy. I think for the third or fourth year in a row, the computer science majors at Vanderbilt have been outdistancing everybody in the engineering school in terms of average starting salary. I think at this point it's over 6 figures, or not over 6 figures, it's over $100,000 as the average, which is pretty darn good. And that probably is the highest on campus, I would suspect. Not sure, but wouldn't surprise me. I know in the engineering school we've been doing very well. Ironically, a lot of those people get the starting salaries are going to Silicon Valley. No surprise, because we have a great connections with a lot of companies there. And the interesting thing, though, is if you've ever been to Silicon Valley, it's really expensive. So you can go there and get like a 600 square foot loft that you share with 5 people, and it's $5,000 a month. But you're very happy with that $100,000 starting salary. So the good news is there are other places that are nicer to live that aren't so expensive. If there's a problem, go up the stairs and out the building. So we always have to tell the evacuation plans. It shouldn't be too hard. Hopefully there will be no problems. Every year there always seems to be a fire alarm or something that's annoying, but hopefully we won't have that problem. Okay, so that is the end of the intro. However, let me do this while we're here. All right. So this is my course website. Again, I'll send out the link to you so you don't have to memorize it. Obviously, if you were here, you figured out where the class is. Here's the final exam. So you can always find out if you start thinking, oh, I have to book my flight home to wherever, you can find out when the exam is. And engineering exams start at 2, so it's 2 to 5. You will not need that long, but that's how long it is. All the office hours, hopefully this goes to the right place. So we have 4 TAs in the class. As I mentioned, they've all TA'd or taken this class. They've all taken this class, and they've all TA'd classes for me before. Every day of the week, we've got somebody covering. My office hours are typically in the morning before class in the atrium. If you go upstairs right outside the Wondery, you'll find me there, probably before 8 o'clock, but you're welcome to come then. And then we have people pretty much all the other times. The office hours, as you can see, are in FGH 226. You may have been there before for other classes, so that should be easy to find. I will put the assignment deadlines out here. We don't have the first assignment up yet, but it will be shortly. So you can always go there and find out when things are due. There's a FAQ that describes kind of commonly asked questions and answers to those commonly asked questions. There's a programming assignment process here that talks about kind of the steps involved, what you need to do. Make sure you take a look at that. Very important to follow those steps. The submission guidelines are really quite simple. Once you have a GitLab account, which you should hopefully have or be setting up, you'll use that in order to be able to push your code, and then I will be able to pull it and review it. There's a summary of the course contents. This gives a summary of the topics we covered last time I taught this course, which was a year ago. It'll probably be slightly different, but it'll give you a tour through the types of things we'll cover in case you're interested in reading ahead. Let's see, coursework, quizzes and final exams, all the discussions of the penalties for not doing things in the right time. Here's the summary of the textbooks. Really, the most important book is Java Concurrency in Practice, which is a really great book written by a guy named Brian Getz and some of his colleagues. Classic work about Java threading and synchronization and so on. We will not do a lot of Android development. Qua Android development, you won't be writing a lot of the app portion of the code. It'll be given to you in the form of the skeletons so that you can focus on the concurrency and synchronization parts. But if you're interested in Android development, there's a great series called The Busy Coder's Guide to Android Development. And it's a great book. It's what I learned Android years ago when I first started playing around with it. There are lots of other places you might look. There's a good book called Java 8 in Action if you want to learn more about Java 8. And there's obviously the Android developers website, various videos. I have playlists from my other classes that I've taught. I'll give you some more hints about that in a second as well. So those are just some things to use as resources in the class. You can also always find all the videos and slides week by week. Obviously, they're all empty at the moment, but they'll be here soon. So what I typically do is I'll have the name of the lecture and which week it appeared in, and then I'll have the link to the PDF version of the slides and a link to the Google or to the YouTube screencast of that. And then the assignments for the course will be available, here, which I will set up. Right now it's empty, but it'll be set up soon. And you can always get access to the stuff there. So those are the typical ways that we'll interact. I should also point a couple of other things out here as well. So I have another course called Digital Learning, and here's where I have links to all the other classes I've taught at Vanderbilt for the past 5 or so years, and the videos of all the lectures. Some of them are not particularly relevant to this, but ones that might be relevant, let's see. Here's a good example. If you want to yeah, there we go. So I'm trying to find the stuff where I had the overview of Java. Let's see. Oh, that's this semester's class. I'll fiddle around with this a little bit, and oh, here we go, playlist. That's what I wanted. So if you need help learning about how to program with Java 8, here we go. This is the link. So this is my course that I taught in 2017. And in that course, I have a bunch of videos that talk about Java's object-oriented features, which I sure hope you know, because that's what you should have learned in 101, and a little bit of 251. And then there's also some stuff in here about Java 8. So if you're curious about Java 8, there's some great videos here, and this is the course that's called, I think it's the fall version of this course. I'll send this stuff out to you with more information. So we also have a MOOC on Android app development, and the first course in that MOOC is all about programming in Java. I don't think you guys need a refresher in Java, but the Java 8 stuff is interesting enough that you might need to learn a bit about that. So if you have questions, I'll be happy to cover them in class or office hours, but a lot of the resources are here online, and I'll send you guys an email shortly that has all the information. Okay, so I think that's basically the non-technical part of the course overview.